What's up, guys? Welcome back to another video. It's your boy Sam. It's been a minute since I've done one of these. I do apologize for the delay, but hopefully I'm not too rusty and you guys get some value out of this video. So we're going to be going over engineering softwares in this one. It's a question I get asked a lot. I've kind of avoided it because I'm not the most experienced with softwares. I was out of my field for a long time, but got a little bit of experience now, done a lot of research for this video. Hopefully I can guide you guys a little bit on what softwares engineers use and which ones are good to learn. We're going to be going over 3 different types of softwares in this video. That's 3D modeling, programming, and simulations. So we'll start with 3D modeling first, but before that, do me a solid, hit that subscribe button. Put a lot of research into this video, so help out your boy. That would be appreciated. So start with 3D modeling. So 3D modeling is something you're almost certainly going to be using in your career. Whether you're with a smaller company or a bigger company, it's something that you're going to use at some point. And which one you're going to be using really depends on what your company decides to use, right? Okay, so here's a nice little pie chart here that I found for you guys. It shows like a market share distribution. Like you'd probably imagine, SolidWorks is pretty popular, but so is Inventor. And AutoCAD, even though AutoCAD's 2D, AutoCAD is still used quite a bit, especially with civils and electricals. Solid Edge, Creo, so a lot of the ones you guys are probably familiar with are, they are used in industry. You guys are probably mostly familiar with SolidWorks because you probably take it in school, as did I. It is looked at as sort of the industry standard, the best one out there. However, that does mean that it costs the most. It starts at $4,000 a year per license. And that means that not all companies are going to use it. Just as an example, I've never used SolidWorks in industry. I've used Creo, AutoCAD, and Fusion. I'm going to talk about Fusion a little bit later because it's an interesting one. But yeah, like I said, it's really dependent on what your company uses. In my experience, the differences in these softwares is not... Like there are some learning curves, sure, especially going from SolidWorks, which is probably the most user-friendly one, going from SolidWorks to Fusion or SolidWorks to Creo. There are some challenges and even frustrations that might come with it, but the basic fundamentals in each one are all the same. So what I would do is, if you want to learn 2 or maybe even 3 of these, pick one of these other ones. There's typically, you can typically get 30-day free trials with most of them, and just sort of see for yourself what the differences are in each. Now I want to talk about Fusion for a bit. Fusion is a relatively new software, and it stands out from these other ones mainly because of its price point. Fusion is $495 a year per license. You can actually get a year free of sort of a limited version. It's becoming more popular, especially with smaller and medium-sized companies who don't need to pay $2,000, $3,000, $4,000 a year for some of these other softwares. It's also unique in the sense that it's cloud-based, which means that you save everything on the cloud. And it also means that you don't need as powerful a computer to run it. Not nearly as powerful as you need with, say, SolidWorks or Inventor. In terms of its functionality, I just want to show you guys how Fusion differs a little bit from these other softwares. So Fusion is a multi-component part system. It's designed so that you basically build all your parts and your assembly in the same file. So you can see here, I just have a little like crankshaft assembly, and I'm going to go ahead and create a part in the file. So I just created a new part. And so I just do all my sketches and extrusions like normal and made it up. And there you go. And that's essentially how it's done. You can import parts, so you can do it that way, but it's meant to be done this way. And if you want to go ahead and edit the part, then you just kind of do it in the same file. I found this really annoying at first, and it's still taking time to get used to, but you can actually build things pretty quickly this way. So yeah, Fusion, it's an interesting one. What I would kind of recommend for you guys, like I said, is you have probably one that you've learned in school, which is a pretty common one, and I would maybe learn Fusion just because it's grown in popularity and it's free. You can get it free for a year. Familiarize yourself with a couple different ones. You should be good to go. All right, second is programming. Now programming, look, I'm not an expert on programming. It's something, I'll say this, it's something that you guys may or may not ever see in your career. I've talked to other engineers, some of them who have never done programming before, and some who have. So like it's really dependent. In my opinion, it's a good skill to have, as sort of I'm learning myself, just because it's so versatile, and it really sucks to be the one who is not able to, let's say, run some of these systems because you don't have the knowledge. So yeah, it's a good tangible skill to have. Myself, who hasn't done coding since university, I'm learning Python, and Python is probably the one that I would say, and that most people will say, is the best one to learn right now. It's the easiest one to learn. It's very versatile. It's being used more and more. We use it at my work for some thermodynamic modeling and even some like basic automating processes. It's being used in machine learning, AI, etc. So it's a growing language. It is the one that I would kind of probably start with. Get good at Python and then go learn, I would probably say C and C++, since those ones are quite popular as well. They're used in a lot of like data acquisition programs, Arduinos, some simulation packages and stuff like that. So I would probably go with those three, but kind of maybe start with Python. Now I want to talk about MATLAB for a sec, because it's kind of interesting. You guys have probably taken it in school, as did I. I don't have experience with MATLAB in industry. I would still prioritize, and I might be corrected here, but I would prioritize learning one of the more common languages, because MATLAB, it is not free. It's not open source. It's its own proprietary language. So that's why you're starting to see companies move towards Python. Yeah, that'll kind of be my summary. Learn some of the more universal languages. Python, probably the best one. C/C++. And yeah, that's how I would go about doing that. Lastly, we're going to talk about simulation softwares. So I said earlier that you guys will almost certainly use 3D modeling. You may or may not use programming. Simulations is one you're very likely going to be using at some point. They're a very powerful tool. They're not totally meant to be relied on, because it's still your job as the engineer to sort of validate that your simulations are correct and that they're accurate. But they can save companies a lot of money just by simulating and not having to test each new design. Now, a lot of these 3D modeling softwares actually come with their own simulation packages, and sometimes these packages are sufficient enough. So for example, at my last job, we designed like a brand new packer, and we used Pro-E to do some structural analysis on it, and that was deemed sufficient enough. But it's not always the case, especially when you're in, let's say, aerospace, or you're dealing with engines, or maybe even an HVAC. Like you need powerful ones. These ones would be like ANSYS, COMSOL, Altair, Abacus. The thing is that it's really tough to learn these on your own, because these are expensive packages. I mean, ANSYS I think starts at like $30,000 a year, and you can't get a free trial. I think you have to be affiliated with the company. But yeah, like, this is kind of why I preach internships, is because if you work at 2 or 3 different places, like you're going to get experience in these packages. The one free one that I know is OpenFoam. It's a CFD simulation package. It does require some programming. I believe it's built in C or C++. From what I know, it is kind of difficult to learn, but if you really want to learn one like that, that'll probably be the go-to. Practice with OpenFoam. That would be a good place to start. You could also practice with the packages that are in your 3D modeling software. Yeah, that would be my advice for simulations. Other softwares that would be really good to know: MathCAD. I've used MathCAD at both of my jobs. It's pretty simple to learn. It's a very powerful tool, especially for calculations and graphing and organizing and stuff like that. Excel is an underrated one. A lot of engineers that I've talked to, they purely use Excel. Make sure you're decent with Excel. LabVIEW, which is used for data acquisition, that's a really good one. We've used it at my previous job. And there's probably dozens of other ones that are out there that some of you guys have used, and you can probably let me know. But yeah, that's it on softwares. I hope that that's sort of an intro to what the industry is like. Like I said, I'm not an expert. I wouldn't say I'm not an expert in any of these, but as I sort of learn more, I can sort of guide you guys a little bit. That's the end of the video. Make sure to subscribe. Do me a solid, like and subscribe. Definitely give me your input. I want to know what your guys' experience in the industry is. And yeah, we're gonna end the video there. Thank you guys for watching. See you next time.
I just brush it off, peep the shoulder moves. We all got the same 24, so it's no excuse. Switch it up, we could rap or produce.